Okay, so for today's lesson, we are going to look at solubility and solutions. So when we look at two terms here that we've actually talked about before, but I actually haven't given them proper titles. So we're looking today at solutes and solvents. So essentially, a solute is the material that dissolves. Whatever it is, in our example here, we have table salt, or we use sugar before. Whatever can dissolve is what's referred to as the solute. The solvent is the material that does the dissolving. So when we mix salt and water, the solute is salt and the solvent is the water because it dissolves it. Or if you were to mix in the vinegar and the sugar, well, the sugar was the solute because it dissolved, and the vinegar was the solvent because it did the dissolving. Those are two key terms that we've been using, but just hadn't given the official titles yet.
So, dissolving. We've used that term so far in this unit and probably in our regular lives to explain different things we've done when we mixed a drink or something else, but we haven't really gotten into detail on what exactly dissolving means and how it works. So let's look at it first. So essentially, the definition of dissolving is just mixing a solute with a solvent, which forms a solution. And we know from our previous lessons that a solution is just a mixture where once it's mixed, we cannot see the separate parts. They're mixed together and we can't see, for example, the salt particles anymore separate from the water particles. They're together in one. Or in shampoo, we can't see the different parts of the shampoo ingredients. They're all mixed together in that shampoo. So that's what it means. How does it work? Well, pretty easy. The particles are attracted to each other. So, for example, if you had in a glass of salt and water, the salt particles are attracted to those water particles. Now, particles in some substances are more attracted to particles in other substances themselves. So, for example here, I'm just going to try to draw a little something here. If we had our glass of water, wow, that's a terrible glass here, and we had, our salt particles, there'll be the S's here. Right now, they're attracted to themselves. So we really haven't stirred this yet. They're kind of sitting there initially and just chilling out. Now, we've got, if I pour in this glass of water particles, and there'll be the red here, they're hanging out here now that we've poured it in. Well, some substances, like salt here, rather than wanting to stay together with each other, they're now more attracted to those water particles. So they start to spread out and move and get closer to those water particles. So we can see here like this. So now they're not together and they're moving in here. They're attracted to that water particle. So with that, that's what dissolving is, because now they're being more attracted to the water particles. They're actually spreading out and moving closer to the water particles and actually filling in some of the spaces in between those water particles as they get together. This would also explain when things don't dissolve. So for example, here again, the salt particles broke away from one another and spread around those water particles because they're more attracted. But some particles aren't attracted. So for example, when we eat the flour in the water, those flour and water particles, when they were in that glass, so this is our flour particles, and we had our water particles, the flour really wasn't interested. It was like, I don't want to go there. I'm going to stick around with my flour particles. And they weren't attracted to the other particles, so they stayed together, which is why they didn't dissolve. So that explains why some things can't dissolve or don't dissolve in certain substances, because the particles aren't attracted. Whereas in our example here, the salt particles were attracted to the water particles, so they moved. This would be the same thing for our sugar that we saw, or Kool-Aid mix, or hot chocolate powder, all those things. Those particles are more attracted to the water particles or the other solvent particles they are, and we have dissolving happening. So, can it dissolve or not? Well, there's a term for that actually. If something is able to dissolve, that term is soluble. That means that whatever the particle or material is, you can dissolve it. So we've learned from our last couple labs, salt is soluble. Sugar is soluble. Chocolate powder is soluble. Kool-Aid mix is soluble. A lot of these things that will dissolve are all soluble. But there's also a term for something that cannot dissolve. So again, there's that hot chocolate mix. The term insoluble means that it's unable, whatever it is, it can't dissolve in that present solvent. So we learned from that last lesson that pepper is unable to dissolve. It's insoluble because it was not able to dissolve in the water mixture or flour. Are there other materials or solvents that could dissolve pepper? Absolutely, right? But unfortunately, in the case of pepper and water, the pepper particles weren't attracted to the water particles and it was unable to dissolve, making it insoluble. So types of solutions. There's actually more than one type of solution. We're going to look at them today here. So the first one we'll look at is a concentrated solution. So what this is when we have a large amount of solute, the thing that's dissolving, in the solvent, whatever is dissolving it. So a good example of this could be if you were making a glass of Kool-Aid and you put a ton of Kool-Aid mix in where you made that drink very sweet and very strong, like it was dark color, and when you drank it, it was really, really sweet, almost too sweet because you put so much of the drink mix in the water. So that's an example of a concentrated solution because really you put a ton of mix in, what's going to dissolve into the water, the solvent. So maybe it wasn't great, it was just really, really concentrated. Another example would be a dilute solution. So this is where you put a small amount of solute in the solvent. So imagine the same idea of that Kool-Aid, but this time you put very little drink mix in. So you put less than a scoop in and stir it in the water, and when you taste it, it really isn't tastes like water still. There's like a little bit of sweetness, but not much because you didn't put enough drink mix in. And that's what's called dilute or diluted because you have far more of the solvent than the solute. So an example, if you look at this chart at the bottom, you can see in the far left the color difference. You can tell which ones have more of the drink mixture or the solute in it. On the far left, it's really diluted. It's almost like just water with a splash of red. But then as we move all the way to the right, you can see it's super dark. That would be a really sweet glass of Kool-Aid because there's so much mixture in it. We kind of know based off of drink mix, probably that middle balance there, the very center glass, will probably taste the best because it won't be too sweet, but it won't be, too bland either. It tastes like water. So that's the big difference between concentrated and dilute is concentrated has a ton of the solute, the mix, and the dilute has not much of the mix, making it taste not so great. So let's look at the next type of solutions. So some more types of solutions. First, we have an unsaturated solution. Now what this is a solution where there's still more room for the solute to dissolve. So essentially, imagine yourself making that Kool-Aid glass again. You've poured in your drink mix and you've stirred it around, you've dissolved it, and it's all gone. It's now dissolved into the solvent or the water. You taste it, but you want some more. So you go back and you pour some drink mix in and you dissolve it again. Well, there was still room. You were able to dissolve more than you had, so it's unsaturated because you could keep adding more to make it sweeter, and that stuff is still going to dissolve inside. So that just means that it's an unsaturated solution because there was more room for the solute to dissolve in the solvent. The complete opposite of this would be a saturated solution. Now, what this is when a solution cannot dissolve anymore. So you've got that solute, you put that drink mix in, you've stirred it around, dissolved everything, and you're like, you want it so sweet, you pour more drink mix in, and as much as you stir and as hard as you stir, there's just a bunch of chunks in the bottom. That mix will not dissolve anymore. And what's happened is essentially all those solute particles have now become attracted to all the water particles, and it's full. There's no more room. All the space is taken up, and there's physically no more particles of water left for the solute particles to join with or to slide, and there's nothing left. So it's full. So you're going to be left with extra particles in the bottom because you can't fit anything else in there. Now that kind of looks like this. So you imagine you've stirred your drink up here. Oh, I should get my pen. There we go. You've stirred your drink, and it's full. You keep stirring, but for some reason, this little chunk of leftover Kool-Aid mix or salt or whatever it is just will not dissolve. So that's what a saturated solution would look like. The final one is kind of a special one. It's called a supersaturated solution. Now it's pretty cool because essentially what it does is it's a solution that contains more solute than it normally would be able to at certain temperatures. So essentially, imagine you have a saturated solution, like right here. It's completely full. you have this leftovers on the bottom, it cannot dissolve it. However, if you were to take that solution now and heat it up and almost boil it so that those water particles are spreading around, shooting around, moving fast through the mixture, well, they're creating more space now, right? We know that heat excites particles and causes them to move farther apart. Well, whereas before there may have been, space for one particle here, well, now by moving apart, for right now, temporarily, we've got a bit more space for those, whether it's salt or Kool-Aid particles, to fit in between and dissolve. So while it's heated at that high temperature, we could dissolve everything. We could keep pouring more in. And that's what a supersaturated solution is. The only problem with this is while it's hot, yes, everything's going to dissolve. But the minute it starts to cool down, well, these water particles start slowing down and moving closer together because they're not moving as fast anymore. Well, now all of a sudden, there's no room for all those particles you just dissolved, and they're forced back out. So they dissolve for a bit, but once it cools down, they come back out. And that's kind of how rock candy is formed, like in this GIF here. You can see that in this mixture, it's almost like syrupy now because all the extra sugar particles, once they cooled, came out and they collected on that string. And that's kind of how you make a bunch of things like rock candy. Because what was dissolved initially in the supersaturated solution is forced out, it's going to come out of the mixture and harden on that rock or on the surface. It's got to go somewhere. So it's only dissolved for a small amount of time. So finally, looking at solutions and solubility, well, you might have heard the term concentration, and it doesn't just refer to your ability to think really hard or long about something. It really also refers to solutions. So what it is it's telling you how much solute can be dissolved in a solution. So essentially, if we were to put 50 grams of salt in 100 milliliters of water, the solution is 50 grams per 100 milliliters. And it just tells us really how much of something is in something else. How much of that Kool-Aid is dissolved in that glass of water, right? Just telling you essentially how much you've put in or how concentrated that glass is. If it's a low concentration, you're not going to have much of the solute. It'll be really watery. If it's a high concentration, you're going to have a ton of solute, a ton of that drink mix in that water to make it taste really sweet. So that's all concentration is. It's just telling us really how much of something has been dissolved in something else. Solubility just refers to essentially the maximum amount of a solute in a solution. So really it tells us what's the maximum number that can be dissolved in water or vinegar, whatever it is. It tells us the solubility. And after that point, they won't dissolve anymore. So it's just that number that tells us how much a solution can kind of handle of a solute or what's going to dissolve. But it depends on three factors. Number one, obviously, is temperature. We know that if we heat certain things up, we can actually dissolve more. But certain types of solvents will dissolve different things at different temperatures. So temperature would be one for sure. Types of solvents, obviously, we know that different things will dissolve different solutes differently. Water can dissolve salt, it can dissolve drink mix, it can dissolve a lot of those things, sugar, salt, all that kind of stuff. But it couldn't dissolve pepper. However, if we had something like a more acidic item or acid itself, acid could dissolve more stuff than water could. So if you have a different type of solvent that can dissolve, it may dissolve other things that water or vinegar, things that couldn't. And also the type of solute. We mentioned here for sure the salt particles in the solute, they dissolved easily into water, but the pepper didn't. But those particles themselves were attracted in the salt and the water to the water particles. But if you get a different solvent, you may have a chance to have that solute mix in. So it all depends on those three things and what's going to dissolve. And then finally, the big term, insoluble. This means that the solute particles will not bond. That means they're not going to dissolve. It can't dissolve because whatever it is, like the pepper was insoluble in water because they were not attracted to the water particles and therefore didn't combine or bond with them. They just hung on their own and we can see them. Same with the flour. They were insoluble in water because with that solvent, it didn't work with. But if we were to find a different solvent, a different material to put pepper or flour in, it might give us a chance to dissolve it instead, and maybe they wouldn't be insoluble in that solvent. So essentially, that should be it for today's lesson. We'll come back more next class here, looking a little bit more at our mixtures and solutions, and actually we'll look at a little bit of how to separate them. So thanks for listening, and check out your OneNote for your small assignment on this lesson.